approach on systematic study on metallic versus composite material structures, which is used in the modern aircraft wings. So here we have the students who are going to explain about the 5 stages of design thinking in the application of the metallic and composite materials structures applied in aircraft and modern Boeing and Airbus series, and they are improve the efficiency and the performance, and also they technically see that they are avoiding the corrosion things happening in the metallic and just good in composite materials, and also they are improved the fatigue life of the wing structures that will do in the engineering phase.
Hi, myself Mukul. I'm a third year Aerospace engineering student, and I'm going to empathize with this following case study. For empathy, we are going to see about aircraft manufacturers. So manufacturers are looking for less complex design and to improve the supply chain, and they want to innovate something in this airfield industry. And then operators and maintenance group. The maintenance group is looking for an easy way of maintaining and easy way of inspection of the aircraft wing. So it's an empathy for the operators. And passengers, it's very important for value of the passenger safety, and it should be affordable, right? So then, when it comes to flight manufacturing, it indirectly affects the passengers, like fuel cost and the taxes everything indirectly affects the passenger. So then the regulatory bodies. So whatever the designs we are doing, that should be under the guidelines of the authorities, and the certificates will be issued overseas. So the environmental concerns, the part of the aircraft wing should be eco-friendly thing, and it should improve the sustainability of the environment. Thank you.
I'm Shruti, third year Aerospace. I'm going to introduce about the stage 2 defined part of design thinking. So in this stage 2, we are going to see how we are going to select the materials used in aircraft, either the metallic structures or the composite structures, which is the problem statement. So in this, first we are taking the metallic structure. Let us take an example of aluminum 2024 T3. So this is a kind of index number. So we can also take titanium. And in the composite structure, we can take CFR3, which is carbon reinforced polymer structure. So in both of these, we are going to see the pros and cons of each section. So in metallic structures, the metallic structure has a pros of high weight to balance and weight to thrust ratio. It will have a high strength, but it will be resistant to corrosion. It will not take up a lot of corrosion when it is exposed to environment. But in composite materials, whereas it will have a high resistance to corrosion, but we cannot identify the damages happen to the material because we will have a multi-layer structure in composite materials. So the next part is structural performance. What are the things we have to see while we are taking different material? First thing is cyclic aerodynamic loading. If the cycle is slow cycle or high cycle fatigue. And the next thing is buckling behaviors. We have to see both pre-buckling and post-buckling behaviors, how the material is affected due to this. So in this defined part, overall we are saying material selection, because a material is the one thing which defines the cost of the aircraft and the life expectancy of an aircraft. This is like a skin to the human body. So we have to choose wisely about the material of an aircraft. Thank you.
Hi everyone, I am Prakash, coming from Aerospace department. Idea understanding the problems and defining the key challenges in the aircraft wing structures. So using that the hybrid solution alternative of the traditional wing structures, like which it is used for metal composite designs, easily adaptive and smart structures, recyclability, life cycle cost. Using the metal composite designs, which it is enhanced the strength, weight and durability and cost effectiveness of the wing structure compared to the traditional wing structure, and then easily adaptive. To directly compare with the traditional wing structure is made up of their metal or composite material, but we can use this hybrid solution, which is really helpful for an aircraft wings. And then smart structures. Smart structures are used in an aircraft wing structures, usually with embedded within sensors, which it is perfectly sensing that the area where the sensors are normally used, the temperature, actuators, like so many sensors are used to place it at the hybrid solution wing structures, and then to totally reduce the maintenance cost, recyclability, life cycle cost of their wing structures, compare them to the traditional wing structure to the hybrid solutions. Thank you.
Hi everyone, this is Shakti from third year Aerospace Engineering. So for the prototypes for metallic and composite structures in designing an aircraft wing, we can use virtual prototype testing methods. That is, we have now here 3 types. Firstly, we can use finite element analysis method, in which we can create a virtual prototype and decide whether metallic materials is good or the composite materials are good. And for the second one, material trade-off. This means which we can do the cost effective and the material cost and everything we can compare with the metallic and composite structures for the aircraft. And also third one is building loading test. In that we can create a prototype that is actual 3D model, and from that we can do a load test from which we can identify whether the metallic material is good or the composite material is good for an aircraft wing. Thank you.
Hello everyone, I'm Riyaz. So for this particular topic, we are having the comparison between the composite and the metallic structures in the wing area, and so we are having the testing. So for this testing, we will have to be having certain things which has to be considered. So here we have the simulation and tool setup. First and foremost, after having the CAD model in your hand, you have to go for the ANSYS or any other simulation software, and then with that you have to input parameters. So the parameters could be about the landing impacts, takeoff lift on this particular wing area, and then you will have to evaluate using these these things such as space distribution, and then the vibration index. Everything you have to be able to calculate, and then with that you will have to be comparatively differentiate which is the best or which is going to be the least fatigue considering term. So
in conclusion, this metallic and composite material used in the modern aircraft tools not only for this comparison, it is also the human-centric approach to understand the design of future aircraft wings to maintain the cost effectiveness and sustainability in future use. Thank you.